Hi guys, and welcome to the our very first webinar. Can everybody hear me now? If you can, maybe just type something in the chat bar. Uh, Great. So I will just wait for a couple more minutes to see if more people arrive. If not, we will just begin afterwards in 2 minutes. Okay, so let's begin then. First off, thanks everyone for coming here. This is our very first Chronon webinar, and I'm the founder and CTO of Chronon Systems, and we'll be talking about all things Chronon today. And so the agenda, I mean, a lot of people here are already using Chronon in some fashion or the other. I guess some people have been referred to this webinar by their friends, and this is the very first time they are using Chronon. So we will assume for the rest of the presentation that you just haven't heard about Chronon, and we'll start right from the very basics. So we'll be talking about what Chronon is, how it works, how you can actually use it in your organization, and what are some of the challenges that you might encounter, any performance issues, and we'll be having a full Q&A session before we end, so you can ask all the questions. So if anybody is still having any issues as far as hearing me or seeing the screen, just type something in the chat window. It seems I cannot make the presentation full screen because that screws up GoToWebinar. So I'll just continue on with this. So, well, first off, what is Chronon? Well, the way we like to see it, Chronon is like a DVR for Java. And by DVR for Java, we don't mean like a screen capture tool, which captures what's on your screen, or like a video capture tool, like GoToMeeting, for instance. What we mean is literally that we can record every single thing that happens in your program and play it back on any machine. So record everything that happens, and all of that is saved to a file on a disk, and then you can take that file and play back the entire application, the entire execution, and see exactly what happened at any point in time, and debug any issues that might arise. Again, this is not an APM tool. Don't show CPU performance graphs. This is completely different. Like, you can literally go and look at the state at any point in your program instantly, and we'll see how you do that. So as far as the recordings go, the recordings are completely system independent. So what we mean by that is to if you have a recording of a Java application and you want to play it back, you don't need anything else other than just the recording files. And the recordings are completely system independent, so you don't need to set up, say, your database or any other like queuing server or GMS server, SMTP server to do the replay. The recordings are also platform independent, so you can have a recording that was, say, made on a Linux machine that's a 64-bit machine and played back on Windows 32-bit machine. We support all platforms that are supported by Java, so whether you're running Mac, Linux, Windows, Solaris, 64 or 32-bit versions, we support all of them. The recordings are also hardware independent. So what what usually tends to happen is most people like to record their servers, which are really, really heavyweight. Uh, they can have, say, tens of cores and much more RAM than your desktop machine. But to play it back and debug the issue on a dev box, usually that dev box is much smaller than your actual production server. So our recordings are also hardware independent. So if the program was at some point occupying 16 gigs of RAM and you want to look at that program in your developer machine, you don't need 16 gigabytes of RAM. And we'll show you how we actually do that in a while. But for now, this slide kind of demonstrates that the recordings truly are system independent. So to use Chronon, you don't need to modify your source code. You don't need to do anything like that at all. All you need to do is add some extra arguments to the command line of your application, and that's it. You're ready to go. So some of the big benefits of using Chronon. Well, first off, now you no longer have these so-called non-reproducible bugs because everything is recorded and saved to a Chronon recording which anyone can play back. So there's no such thing as a Heisenberg or any of those race condition issues which are really tough to reproduce. You don't need things like putting logging in your code. You don't need to clutter your code with logging at all. And we have a special feature for that called post-execution logging, which we'll be showing you later in the demo. But you can completely do away with logging, which is a huge win. And of course, once you have a Chronon recording, it is really easy to share bugs within all the groups in the organization. So you can share between QA and dev, or say support and dev. It's really easy. You don't have to like type in exactly the steps to reproduce the bug or the environment to reproduce the bug. And the guy who's trying to debug the issue, so let's say if a QA person finds an issue on their machine, for the developer to debug that issue, all they need is just a recording file and maybe some rough description of what the issue was. They don't need the exact steps to reproduce the issue, and they don't need the original environment. So if the issue happened, with say a database and a queuing server and an SMTP server all set up, the developer doesn't have to set all of that up. All he needs to do is just take the recording file and play it back. So really easy to share recordings within groups or even within remote teams. It is really easy to communicate bugs because all you have to do is send them the recording rather than being on the phone with somebody for hours trying to describe what the actual bug is. Now, whenever I do talk about Chronon and whenever I do talk about recording, the first question that always comes up is performance. How is it going to impact the performance of my application? And is it just going to slow everything to a crawl? What's going to happen? So this is a small slide that's a study done by New Relic. It's not done by us, and maybe a little too small to show on the screen here. But what this shows is, like, if it takes 6 seconds for a web page to load, out of those 6 seconds, only the 0.6 seconds are spent on the servers. Only the 10% of the time is spent on the server. The rest is spent in the network or rendering in the browser. And it's that 0.6 seconds that's where you're going to actually run Chronon on. And note that these 0.6 seconds, they take into account all kinds of things like communication with the database, the garbage collection, and whatever. So our impact is really just going to be here. So it's not going to be too high at all, just in the first place, seeing how most enterprise applications work. So as far as performance goes, we believe that scalability and the ability to control performance is much more valuable than just raw performance. And this is evidenced by people using things like Python, Ruby, or whatever other languages, which are, in a sense, a few x, say 5 or 20x slower than Java. but they still use it because they can control the performance and they can scale it out with additional hardware. So throughout the architecture of the Chronon recorder, we have made it such that you can scale the recorder very well with additional hardware, or you can control the performance exactly the way you need to. So the way the recorder works is it excludes all the code that is not your code. So if you think about any Java application, it's going to use a bunch of third-party libraries. At the very basic, it's going to use the JDK libraries, right? And a typical J2E application is going to use your Tomcat, Spring, Hibernate, a bunch of third-party libraries that you did not write. And since you didn't write those libraries, you cannot debug them anyway, because, I mean, first off, you probably don't even have the source code for those libraries. So we don't spend any cycles trying to record stuff that is not your code. And you tell Chronon what to record, which portion is your code, and we will record only that. So that way you can really control the performance of Chronon. So in the case that you do the code that is being recorded calls some third-party code, what happens is we will record the inputs and outputs to that third-party code. So let's say you have a method called readFile, and readFile is in some third-party library, and you're not recording it because you don't really care how readFile works. Maybe it's implemented by the OS, and you don't have the source code for it. All you really care about in that case to debug your application is what was passed to readFile, the arguments, which in this case would be probably the file name, and the return value, which is probably the byte array, and we will record that. So the way the recorder works, by default, everything is excluded, and you tell what to include, and usually that's just a single line of configuration which specifies the namespace of your code, something like, say, org.mycompany.**, and that just takes care of everything. So there's no heavy configuration that's required to use this. It's just one line which says the namespace of your code. This is a diagram showing how the Chronon recorder actually works. This is the architecture. So you have the threads of your application. Let's see if I can turn this off. You have the threads of your application which are being recorded, and they are continuously generating data which is saved to this buffer in memory. Now you have these other flusher threads which keep taking all this data from this buffer and keep persisting it to the disk. So if you want to scale Chronon, at least as far as hardware is concerned, well, the easiest way is to increase the size of this buffer. So you can increase the amount of RAM that you give to Chronon by setting a higher XMX value, like 4 gigs or whatever. The second way is to add more cores. If you have more flusher threads or more cores trying to flush that data out, well, then you won't get that out of memory exception. The third way is to increase the performance of the write performance of your disk. So we can flush the data out faster. So you can either buy a faster disk, or what you can also do is you can use NFS and put the destination for the recording on a network file system. So all the data that's being persisted goes out through the network. And that in some cases is a lot faster than trying to thrash the disk off the server that is actually doing all the work of the application. So you can increase memory, CPU, or the disk. All three cases we allow scalability. The easiest way to scale Chronon, though, is to add more memory to keep the size of this buffer large enough. And that's also the cheapest way, because RAM is the cheapest component that you can buy currently. Now, usually a question that comes up when we talk about a big buffer like this is Java GC going to interfere with the extra memory? Because we all know Java GC does have problems if you go above the 2 GB mark, and usually the pauses are too much for the application to handle. And we have spent a long time designing Chronon with our own custom memory allocation mechanism. So even if the amount of data that is in the buffer goes to a very high value, it won't impact the GC at all. So you don't have to worry about GC, at least as far as the Chronon data, the recorded data in the buffer is there. And again, the buffer keeps getting flushed out by these flusher threads. Keep that in mind. But people who are really sensitive to anything impacting the performance of the application, we have this functionality called dynamic start-stop. And what dynamic start-stop does is it allows you to keep the recorder in a completely dormant state till the time that you actually need it. So you can start and stop recording in the middle of a running program. And when you hit the stop button to stop the recording, the recorder is completely detached from your program. So any extra instrumentation that is done, any extra memory that we take, all of that goes away when you hit the stop button. So the places where this is used and the big value add is, say, in a very highly performance sensitive production system where you probably don't want to run Chronon all the time because of the performance constraints. What you can do is you can start the recorder the first time you hit a bug, and then you have to reproduce that bug just once so that it gets captured in a Chronon recording. And then you can stop the recorder again because the recording has not been captured, and share the recording among all your developers. And they can literally debug the issue in parallel. They can all look at just their portion of the code to see if an issue occurred. This is much more better than the alternative, which right now is essentially somebody has to sit through the whole night or whole weekends, sometimes many days at a time, adding an additional logging to the program, adding additional levels of logging to the program, or sitting with a remote debugger somehow. And you still have to reproduce the issue, like if you're not using Chronon, tens and tens of maybe even hundreds of thousands of times to actually debug and find the root cause of that issue. And we reduce that to just reproducing the issue once with the help of dynamic start-stop. So that's the recording part, and let's get back to the replaying part, right? Now, if you really think about it, there's no point of just replaying something. I mean, if you can't look inside what's going on in your program, because I mean, we can just put up any process in your dev box and have it consume CPU and memory and call it a replay if you're not looking inside it. So we had to build really next-gen sort of root cause detection solutions to help you debug all these wrong-running applications. And we thought, should we actually do an actual replay of your program when you're trying to debug these recordings? And we decided against it because we believe there are a lot of problems with actually re-executing your code, because you get into all these issues like your recordings are no longer system independent. You know, something that ran on 64-bit, you have to run it on a 64-bit machine again. You get dependencies like being tied to a platform and hardware. If you're replaying, you still need the same kind of hardware to actually do the replay. Like you need the 16 gigs of RAM again on the machine that you're replaying on. And if you actually did a replay again, we'll have to use your standard traditional debugger, which does not work for long-running programs. Like how will you debug something that's been running for 5 hours with a traditional debugger? Will you press a breakpoint and wait for 5 hours? That just won't make sense. So the big problem that I mentioned right now with replaying again is the issue of hardware, where your server is much bigger than your dev box, and you would either need to buy the server like for all your developers in order to actually play the recording back. So what we decided is when you actually do a replay of your program with Chronon, we don't actually execute any code. So there's no code that's being executed. We kind of give you this illusion of execution. So if you jump to any point in time, we'll show you the entire state, but we pull out only the amount of data that's visible on the screen. So a good example of this is Google Maps. So when you look at the Google Maps view of a street, you only need to download the part that is on your screen, and you don't need to download the entire earth onto your desktop just to view a single street. The same happens with our what we call the time traveling debugger. When you're playing back your recording, we only need to pull out the amount of data that is on the screen. So in this case, the stack trace or the local variables, etc. And that's only like a megabyte or so, usually a lot less than that. So because of this, even though your program was say taking 16 gigs of memory at a point in time, we don't need to use all 16 gigs when replaying it, because you cannot look at 16 gigs of data on your screen and possibly fathom something out of it. So we only need to pull out the amount of data that is on your screen, and that's what makes the recording hardware independent. And you probably would have guessed by now, because we don't re-execute your program. The recordings are essentially almost like a database that we query to recreate the state of your program at any point in time. And we'll see how that works as we move on to a demo. So speaking of debugging, as I said, we really have to rethink debugging for programs that are built for 2011. I mean, if you take a traditional debugger, it was invented in the 70s, and it's really not designed for programs of 2011, which run for long periods of time, which are multi-threaded. It's just not meant for that. I mean, and the GUI and everything about the debugger screams that. I mean, you have these stepping buttons which assume sequential single-threaded execution, and you have this weird breakpoint model. And again, something like the breakpoint model does not work in a long-running application because, as I said, like, are you going to set a breakpoint and wait for an hour for it to hit? And you never solve the issue the first time you hit a breakpoint. So are you going to spend like hours just sitting and hoping your breakpoint hits and you hopefully debug your issue? So it all just does not work. The only real way people debug right now is, well, through logging. And logging is just fundamentally broken because, first off, it adds a lot of clutter to your code, and secondly, there's this huge paradox that we call the paradox of logging, where you put a logging statement where you expect an error to occur, and because you put the logging statement where you expected that error to occur, you already hardened the code at that point in time. So when an issue actually occurs in production, it's usually where you didn't put that logging statement because you never thought an error could occur. So we had to build a new debugger. It's built for the 21st century, as we like to call it, and it allows you things like jumping to any point in time without delay, so you can actually debug a 5-hour-long recording and just jump to, say, the end of the 5th hour instantly without any delays at all. And especially it is designed for multi-threaded programs of 2011. So there's a lot of cool stuff in there, and let's just move on to a demo of the product. So what we have here, what you're looking at right now, is what we call the Chronon recording server. This is our official solution for recording machines, and what this allows you to do is connect a bunch of machines and manage the Chronon recorder on each of those machines. So over here I have this one test machine that is connecting to the recording server, and it shows me all the JVMs on that machine. I see one JVM, and it's running this application Jira, and the machine in this case is on this VirtualBox VM, and you can see Jira is running, and it is being recorded as we see the status says recording. And I can interact with Jira here, and you can see Jira is just behaving normally, and everything that we're doing right now, by the way, is being recorded by Chronon inside Jira. And you can see there's nothing, there's no performance issues, nothing is grinding to a halt. And what I can do is, while Jira is running, I can start and stop recording dynamically. So I've stopped recording in a running Jira application. You can see Jira is still running, and subsequently I can go back and start recording too. So I stopped the recording and I started again, all while Jira was still running. The person who was using Jira in this case doesn't even need to know that recording started or stopped. And what I can do now is I can take any of the recordings, I can download them and debug whatever was in that recording. So the recording server takes care of all kinds of things for long-running applications. So it takes care of, in this case, splitting the recording so that the individual recording size doesn't get too big. So over here we say, okay, split the recording every hour. So every hour a new recording will be created. So if, say, an error occurred between 11 and 12, you can pull out the recording from the recording server between 11 and 12. And of course it prevents the actual physical recording from getting too large. It will also take care of flushing old recordings, so just so that recordings don't occupy the entire disk space, you can configure it to say delete any recording older than 30 days or whatever you want. And this is also where you can specify what I told about the configuration of what is needed to be recorded. So over here you see we have the simple configuration, one-line configuration, which says, okay, this is what you want to record, and the rest of the stuff is left out. So all Atlassian code we are recording, and all the third-party code like Tomcat, etc., is being excluded from the recording. So as I mentioned before, I can just take this recording and just download it and then play it back in my time traveling debugger. So let's see, let's try to open this. What was the recording number? 93. So I just specify the path to the recording, and oops, that was an empty recording. Let's see, I have a recording from previously. So this is recording number 89, and now before you can actually use the recording, you'll go through this short unpack phase, where what we do is we take all that really highly compressed recording data, and we can extrapolate the data and index it so that the debugger can query the information and give you all kinds of info. So this is a recording of Jira. This is an hour-long recording, and over here you can see I have this bunch of thrown exceptions, and I can click on any exception, and I can jump directly to the point in time when that exception was thrown. So this is the number format exception, and I jump to it instantly, and as you can see, I can see the entire state. Let me put this here. I have the entire stack frame. I have all the values of all the variables at this point in time, and I can see, okay, this number exception was thrown because this duration string is not exactly a number. And again, we jump to this point in time instantly, regardless of how long the recording actually took to run. So this exception could have been thrown, say, at the end of 59 minutes, and we would still jump to it instantly, no matter how long the program actually took to run. So just to go through all the capabilities of the Chronon time traveling debugger and how you can use it to find the root cause of applications, I'll switch to a different program, something which I'm more familiar with. I'm not familiar with the Jira code, but this goes on to show this goes on to show how the workflow looks like with Chronon. You have the recording server, which is recording your machines, and you can download any recording and play it back on your machine. So let's see. I'll record a small program here. You can also record from within the Eclipse IDE if you have your plugin. And instead of pressing the green run button, you can just press the blue record button. And so I will go and record this small application. Now this is like a 100,000 line application, and it did a bunch of stuff, and everything that has been done now was recorded and saved to a file and disk. And now we will start debugging that recording. You see, the first time I open it, it does this little unpack phase where it indexes all the data and increases the size of the recording so we can read it really easily. And it'll take just a few seconds for it to unpack. The unpack process is completely parallel, so if you have a lot of processors, a lot of cores, you can make that unpack go really, really fast. So on my screen right now, you can see this is the debugger running off that recording that we made previously. And just like your standard debugger, I can step forward and I can step in, and you can see as I step forward, the state is changing, the stack trace is changing. Just exactly, it feels like my program is actually executing. And I can also step back. You can see the values change over here as I step back. B went to 0, and I go ahead, 7, then 0 again. In the case of 5, it changes to 6. But then again, we thought you can, the back button, although it's useful, there's a lot of things that we can do with all the recorded data that would be much more useful than just a back button. So in this case, you're seeing this little green line over here, and this kind of looks like code coverage a little bit. Let me expand this. You have this green line. Although it looks like code coverage, it is not code coverage. This is what we call the execution path. So code coverage shows you, well, the execution path of all the calls of your method in a cumulative fashion. But the execution path in Chronon shows you just the execution path for that very call to the method. So in this case, we know just by looking at this the execution path to this demo method, we see instantly that this else statement was executed, but this if statement was not. And if there were like multiple calls, if there was a different call in which the if statement was executed, when you would step inside that call, you'll show the if as highlighted, but the else not as highlighted, which is something a code coverage tool will not do. It will just show you cumulative. So if two different method calls took the if and else, it'll show you the green line across both the if and else. So you can have a million different calls, and we will show you a million different execution paths. And that is just to give you an idea, without stepping in your code, what path it took. So as I said, I can instantly see that the else was taken. And instead of just stepping over one by one, we can just actually click on the execution path and just jump directly to that line. So I can just jump directly to any point in time, and the state keeps changing as I do that. Where that kind of breaks down is this loop. I mean, you have this loop from 0 to 10, and how do I go across this? And again, in a standard debugger, like this would be tough to debug if the loop was really long with a breakpoint, because you don't know which iteration of the loop caused an issue. So in Chronon, what you can do is you can just click on I. It'll show you all the values that were ever assigned to I, from 0 to 10. And if I click on any value of I, it just takes me directly to the point in time when I was assigned that value. So 5 in this case, or if I click on 6, then 6. And from that point in time, I can step forward, let's see, change to 7, or I can step backward, change back to 6. So I can look at any loop, any iteration of the loop independently. Another thing that's a bit of a peeve is lines like these. Like you have nested calls on this line, and a lot of times you must have seen a stack trace, and it shows you, okay, an exception occurred on this line, but that line has multiple statements, and you don't know which one of those statements caused an issue. And over here, we don't know like what's the return value of binary search and what's the argument to result. And usually this would require a lot of stepping in and out in a traditional debugger. With Chronon, we show you exactly what is happening. So we have this current line view, and it shows you, okay, there are 2 calls in this line at this point in time, and you can expand to see the arguments and return values of each call. And you can click on any call and just jump directly inside that very call that you want to look at. So you must have noticed something, that we don't have any breakpoints in Chronon. So how are you going to debug without breakpoints? Like, are you going to step all the way? So let's say I want to examine this binary search method here. So since we don't have breakpoints, what we would do is we would place a cursor inside the method. And instead of putting a breakpoint, we'll just say run to method forward in time. And it'll just jump directly to the next call to that method instantly. So you don't have to deal with breakpoints. You just say, go inside the method and say run to method forward in time. And I can see the entire execution path, the whole state of the program has been changed to show me what has happened. But again, there can be many calls to this method, and you don't want to hit that green button like millions of times. So for that, we have this method history view, and it shows you all the calls that were made to this method. So we can see there were 10 calls, and it shows you things like the thread which called that method, the return value, the arguments, etc. And I can click on any of these calls and it will just jump directly to that call. So as you can see, as I click on each call, the execution path is changing. And as I said, we keep the execution path for every single different call exactly how it was. You can see the execution path changing, and that gives you proof. But again, there can be lots of calls to this method, and we need some way to filter it. Like things like you want to see, okay, I want to see only the calls which were made on this thread, or when the value of this variable was so and so, just like you would do in conditional breakpoints. So we have this functionality called filter, and if you click on this gives you this really rich set of filters which were just not available in conditional breakpoints. So I can say, okay, show me only the methods, the calls to this method that were made on the thread name main, and where the value of the local variable mid, say, became greater than 4. I can add that expression, and I can also say, okay, and where the line hit was 40. So I add these 3 expressions and I do a search, and it shows me only the calls which match all those criteria. So all these calls, they hit line 40, and the value of mid goes above 7 in all of these calls. So we can really filter down the exact method or the exact piece of code we want to look at really fast and really easily with this filter functionality. And this is one of the most powerful features of Chronon. Again, you have the thrown exceptions view, which you have already seen right now. You can see all the exceptions that were thrown. You can click on any exception and jump directly to the point in time when that exception was thrown, and you have full state, and you can step back from that point in time and see what is it that caused that exception to be thrown. And this is where the step back really comes in handy, because you don't just want to step to the point in time when the exception was thrown. You want to step back from there and see what was it that caused that exception to be thrown. So again, this program, it printed out a bunch of stuff on the console, if you might have noticed. But the program has already ran, and we still probably want to look at the console output. So for that, we have this recorded console view, and it shows you everything that was output to the console by this program using printline statements. So here we have this warning statement, this red line. And usually in a 100,000 line program, if somebody were to ask you to figure out the root cause of a warning statement, it will take you a long amount of time. And this is kind of how it would happen in a real world, in a long running program. Even with logging, you would just have this one statement to go by, and you would just have to literally look at your code and see what happened that caused this warning statement to be output. That's all the information you'll have. You'll have this little warning statement. With Chronon, you just click on this output, and it just takes you directly to the point in time when that warning was output, and you can see the entire stack, all the state, you have all the variables, and then you can step back and see, okay, what is it that caused that warning statement to be output instantly. So again, you can see I have full state over here. I can expand all these elements. I have all my state over here. So something like if I want to see why this disclosure busy became null, I can click on it and just jump directly to the point in time where the closure busy became null. Something that will take you a long time with the current debugging mechanisms, just to find out things like these, like why did this become null, or why did this become this value, or whatever. There's also the recorded threads view, which shows you, okay, what were the threads in the application, and that gives you an idea of how many threads were actually executed. This is note that this is not how you filter by threads. If you want to filter, if you want to look at the piece of code called the thread, you would have to go to method history and then do the filter from here. The recorded threads view just shows you the actual threads that were running, and you can just go to the beginning of a thread that you want. It just shows you what threads are executing. Now, as you might have noticed till now, we're not just stepping forward in the execution of a program. We are stepping all over the place. We are sometimes stepping back, forward, and we need some way to keep track of where we are in the execution of a program. Otherwise, we'll be completely lost. So we had to build in Chronon what is essentially a clock, so you don't get lost in time. And the clock in this case is the timeline view, and it shows you right now the current time. So time in Chronon again does not relate to any wall clock time. All it does is it shows it is given ordering on events. So something that happened at time, say 5 or 6, happened before something that happened at time 12. That's all that it denotes. And that will give you an idea of when you jump to something, whether you step forward in the execution or you step back. So you see everywhere you see anything in Chronon, we show you the time value, just so you know the ordering of what is happening. Otherwise, you'd just be completely lost. And we have this little progress bar here, which kind of gives you an idea of how far down the execution of a program you are. So if you jump to, like, so right now the bar is empty because we're at the beginning. But if we jump to this exception, the bar kind of fills up. So we know we're kind of near the halfway of our program. And again, if I go to, say, back to the main method over here, and if I go to the absolute end, the bar completely fills up. And this gives you an idea of how far down the execution you are. Something to keep in mind, something that's really useful but not the flashiest part of the demo, is time bookmarks. These are bookmarks in time. So if you look at something interesting, you want to jump back to it, you can just place a bookmark there and jump back to it whenever you want. And although this does not look flashy, this is absolutely essential to be able to debug your programs with Chronon. If you're not using time bookmarks, then you just don't know how to use Chronon to debug your programs, because you just have no ordering or any idea of what you're looking at. So if you're looking at an exception, you want to know whether that exception was thrown before the point of interest or after. So if it was thrown, say, before the point of interest where you place that bookmark, you probably don't care about that exception. So time bookmarks are absolutely essential to you using Chronon. Also, we have these back and forward buttons, and these are like the back and forward buttons in your browser, and they keep track of the last and calls to the method that you are in. So same method but different calls, and they like to quickly get back to what you were looking at. So if you jump, say, to this exception, or you jump to when this thing was assigned as hash set, and you want to quickly get back to where you were, you can use these buttons, like the back and forth buttons. Now, this is all real good, but a lot of people always ask me, what about logging stuff? Because we have a lot of log statements in our program, and can we see them in the recorded console view? And again, as I said before, we hate the idea of logging because it clutters up your code and it's fundamentally broken because you have to try to predict your errors. So what we have come up with in Chronon 2.0 is this idea of post-execution logging. So what you can do is you can actually add logging to your code after it has run. So you can remove all logging statements from the program and add logging whenever, at any point in time after the program has run, and see the results. And I'll show you a demo of that real quick. So this is we will put the demo on our own Chronon code. So this is a part of the Chronon recording server. It has all these logging statements. I will go ahead and remove some of these logging statements. You don't need to do that, but this is just a demo that you don't need to clutter up your code with logging statements at all. So I'll remove these few logging statements from here, and now I will run this program. So this is running right now with recording enabled and without all the logging statements. Let's see, if I go here, that actually just added another machine. So this is just a list of the machines and all the JVMs of the applications on that machine. So I use that program a little bit, and let's see, I will now stop it. Where's the program? I will go ahead and stop that now. So now that program has run, and now we can go ahead and debug it. So I'll take a few moments for it to unpack the recording. So now the program is replaying, and now I will go ahead and add logging to any point in my program. So I click on this post execution logging panel, and I go to, say, the start method, and I will add a logging statement here which says, let's say, starting, and I'll add it to the method entry. And let's see, I will go to, say, this method over here, connect, and I will add something which says trying to connect. And note, these are not just gimmicks, so I have full access to state over here. So I can say this dot, let's see, I have server address and server port. This dot server address and this dot server port. I'll add that, and let's add a few more, just a couple more. This is where we remove that logging statement. I'll just go add one over here now since we removed it. This one says connected, and let's see, for disconnected. So this one will say disconnected. Okay, so I added my logging statements, and I will go ahead and run logging. And as you can see, I instantly get the results. This is exactly how the results would look like if I had actually placed those logging statements in my code when I was running my program. So I can see it started, it tried to connect, and it then connected. And I can click on any line of output, and in true Chronon fashion, it'll just jump to that point in time when that logging statement would have been output had we actually put that in the code that we put it there. So let's add one more statement just to add more detail to this. I will go ahead and add one on this line, line number 36, which says, I want to see all the messages that were output. So I can do this. Usually you wouldn't do something like this because the overhead of logging all the messages in your that were received in your application can be really, really high. So you just would not log this thing, but a lot of times you will need to see this. But since you already have a really good, really optimized logging mechanism, you don't have to worry about that in Chronon. And now I will go ahead and add this post-execution logging. And when I execute it, it shows me all the messages that were output. And I can click on any message, any line of output, and it shows me directly to the point in time when that logging statement would have been output. And as you can see, I can see all the state of my program here, see all the threads. So when you go to a point in time, it's like a vertical slice in time. You can see all the threads that were active, all the stacks, and the entire state of that stack. So that is post-execution logging. You can remove all the logging from your code completely and add logging wherever you want and see that instantly. Again, focus on the instantly part. Even if your program ran for 5 hours and you did the play over here, you will see the results instantly without having to wait for 5 hours. So that's it for our small demo of our time traveling debugger with the post-execution logging, and that shows you how you can use it to find the root cause of your issue. So as far as products go, you've seen two products today, the recording server and the time traveling debugger. There's a third one called Embedded Chronon, which I'll talk about in a moment. But as far as solutions go, for the recording server is our official recording mechanism, and the time traveling debugger, we see that as our playback mechanism that you can use to play back your recordings. This is how the architecture of a system with the recording server looks like. You have your machines which are being recorded. You install a small controller process on each machine which communicates with the recorders on all the JVMs on that machine. And the recording server in turn talks to all these controllers. The recordings are saved locally on the computer that you're recording, so there's zero network traffic when you're running the recording server. So you don't have to worry about network traffic at all. Even if any of the nodes go down, any of the computers or the recording server, the rest of the system will keep working as you configured, because it's the controller that is actually managing the recording on these machines. The controller is a very lightweight process. All it does is it acts as an intermediary between the recording server and the JVM. So you can keep it running in the background. The way you do that is you install it as a daemon process during the installation process of the recording server. As far as embedded Chronon, now this is something that we don't have on our website yet, but we are working with some of our partners. This is not exactly a product as much as it is a licensing solution. And what it does is it allows you to put a record button inside your application. So this is something that's meant for ISVs. So the recording server part, that is meant for use internally, like you install it on the QA machines, production servers, staging servers, or dev servers, but those are internal. But if you want to ship Chronon with your application and provide, say, a support button inside the application somewhere, that is where the embedded Chronon comes in. And what this allows you to do is basically ship the Chronon recorder with the application. And in this case, we will be providing you access to the recorder APIs that we use, like recorder.start and stop, to actually start and stop the recording dynamically and things like that. So you can create a custom solution around Chronon technology that you can put in your application. So you can build a solution that has a recording start-stop button, and which takes care of actually transferring the recording from your customers to your support or dev team. And a good demonstration of what we can do with those APIs is the Chronon recording server. That is our solution, which shows the power of these APIs and what you can do with it. The licensing on these is obviously on a per case basis. So that's it for our demo for today. And now we can take some QA. Anybody has any questions? You can speak them out loud, or you can even type them in the questions box, I believe. I will wait for 1 minute for any more questions. Okay, let's see. Can I expand this? Okay, so let's see. So I will go at it line by line. So can I provide options to not to record user-sensitive information in a production environment? You can do that. You can exclude the classes in your code that contain user-sensitive information. That's where the include-exclude functionality comes in. So if you have something which says the class which holds, say, a username and a password, you can just exclude that class, and you won't be able to see when debugging the value of the fields of that class. So that's how you can protect the user-sensitive information. The recording of this presentation will be available on the web at some point. how will you debug a WebSphere? Well, the same as the way you debug a JBoss or whatever. So you will just be you just need to add a couple of extra arguments to the launch of your WebSphere, like something like, well, let's see, do I have the, if you can see this window. So this is how, this is the couple of arguments that we added to Jira. We added basically a Java agent and a Java agent argument over here, these couple of lines from here to here. That is what you will add to, and it is literally just these couple of lines. The config the text is just 2 lines. I mean, we hate configuration ourselves, so it's literally kept to just 2 lines, which say, okay, use server mode and a name for your application, which in this case was Jira. So this is all you need to do to record WebSphere, Tomcat, or whatever you want to record. Are we ensuring thread order during while replay? Yes, thread order is completely retained. When you look at a point in time, it is exactly how the program was running as far as all the threads were when you were actually doing the recordings. Now, so some people who have used Chronon, and if you notice during our short demo, is we exclude the Java namespace java.star while recording. And because we use Java classes inside our Chronon, and we can't record them because that will cause an infinite loop. A side effect of that is that you cannot look inside collections because things like array list or hash maps are not recorded. But so although you cannot look inside the array list or hash map, we have found in all cases that you can still debug your issue. And I will show you a solid example of that in here. In which the bug really is related to an actual collection. So if I go back to this warning message, and if I want to find the root cause of it, I just go up a few stack frames above, and it shows me this error message is called if the size of disable alts is greater than 0. And if you see over here, disable alts is a hash set, and you cannot look inside the hash set because we cannot record it. But let's try to debug the root cause of this issue. So disable alts is assigned this value over here. I can see that just with this execution path. So if I click on this line and I go inside, if I step inside, by the way, we have keyboard shortcuts for every operation in Chronon now. So all these operations, step in, step out, or literally everything has a keyboard shortcut, so you can debug really fast if you want. So anyway, getting back to the issue, this is where that set was created, and just by looking at the execution path without even needing to step through, I can see some elements were added to this set, which was eventually assigned to that set we were looking at, disabled alts, and that is why that error occurred. So so even though it is not as convenient to see the size of, to see what is inside the collection, the fact that you can move forward and backward in the execution of a program, the information is still there. So it is just not as convenient as having the actual what's inside that collection. And again, remember, if you didn't have Chronon, all you would have to go by is this one statement probably somewhere in your log file, and that's all you will have to debug your recording. So even though it is not convenient to be able to look, not as convenient as being able to look at the collection, it is still far more valuable than the alternative right now, which is to use logging. So that takes care of that argument, hopefully. As far as code being in sync with your recorded code, the way people usually work around that issue is they assign say a change list ID to a recording ID. So what you will usually do is say, let's say you have this instance of Jira over here, and it shows me the recording numbers. And usually if you see a bug over here, say in recording number 94, what people usually do is they in their bug tracker, they note, okay, recording number 94 is associated with, say, perforce change list 2532 or whatever, the revision of your recording of your source code. So the person who wants to debug the issue can then just check out that revision on the desktop and play back the recording. That's how you kind of associate the recordings with your code. It's not integrated by us, but the reason for that is just not a big issue. You usually have somebody who has already put in the change list information in a bug tracker somewhere, which corresponds to a recording ID. So I guess Jasper and Ryan Fong, does that answer your question about collections? Okay, yeah. So the thing to understand is there are some limitations, with things like collections, etc. And because you're not recording all the code, but the value add that we offer compared to logging, the sparse information you have in logging, is extremely, extremely high. And it's usually just a matter of inconvenience rather than the information not being present. The fact that you can step forward and backward just completely does away with that. So Pashupatinath, like when you talk about best practices, what exactly are you talking? You can also speak in the mic or your phone if you want. Let's see. Okay, everybody is muted. Let's see. I'll type it. Well, somebody asked about best practices, so I'll throw in a few links here. Something you probably want to take a look at is the Chronon Performance Guide, and this shows you how to scale Chronon. And let's see, hopefully I can get this all back. Okay, so for some reason I can't type into this bar, but something you want to look at is the Chronon Performance Guide. We do have a bunch of video demos on the website which act as tutorials for all of for how to actually debug your program. So those are some things you probably want to take a look at. Any more questions from anyone? Let's see. I will wait for. Yes, there is an export to PDF option, I believe. Let's see. There is an export to PDF option over here. So you might also want to look at the Chronon internals, where this is a bunch of posts talking about some of the internals in Chronon if you just really want to learn it. I don't know what you mean by page-wise. It is well, when you make a PDF, it'll make a PDF for this document, this web page that you're looking at. It won't make a PDF for everything in there. Well, as I said, if you do have as I said, for really sensitive information, you have to exclude the stuff that you don't want to record. Usually it is maybe some class like user or whatever. You exclude that class from recording if it contains the username or password. What happens if there's a discrepancy between the recorded binary and the source code during playback? Well, I mean, when we as far as discrepancy goes, all that will happen is when you try to step to a line in code, that line will seem out of out of context. So what will happen is all that we do as far as source code is concerned is when you click is navigating to it. So when you click on the stack trace, we know, okay, this is the class and this is the line that the stack trace was in, and we'll ask Eclipse to, okay, open up this class and just navigate to this line. So if your source code is not in sync, when you when we tell Eclipse to open the class on that line, you will see something that just does not correspond to what is in all the different views of Chronon. Like it will show current line, maybe the current line will show a call to say foo, but you may have a call to bar on that line. So that's all that will happen is you will see weird stuff like when you try to jump in, like the code that is in the rest of the views won't be what is in the editor. So any more questions? All right, so it seems one more minute for just maybe one more question. Yes, that's the whole point. You can record in cloud. That's what we showed right now. That you can record remotely. Yeah. You just have to have the recording jar in the recording server. As long as you can add an argument, you'll be able to record. So the as far as the pricing goes, we have the pricing for the time pattern debugger on our website. Is licensed per developer at $240 for a commercial license and an annual subscription. As far as the recording server, we have not disclosed the pricing because it is still in beta. If you do want to purchase it, a lot of people have purchased the recording server already because we can offer you discounts while they're still in beta, and we will get out of beta this month. So the recording server will be licensed per JVM. It'll be licensed. The pricing will be similar to the runtime and APM level tools that are in the Java space. And if you want to find out more before we release the final product, you can contact us at sales@chrononsystems.com. When it is released, the pricing will be on the website. But if you want to buy it at a discount now, you can call us. So anyway, we're running out of time, and I can just take one last question if somebody has one. So I'm going to count in 10, and if nobody comes up with a question, we will go off. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Well, thank you, everyone. Thank you for attending our webinar. If you have any more questions, feel free to ping us or shoot an email to support@chrononsystems.com, and we'll help you out with all the issues. Thanks a lot. Goodbye.